Okay, good day class. So for today, we're going to learn how to process linear differential equations and how do we establish it to be linear in the first place and treat it with the procedure for linear first order differential equations. So just like the separable differential equation, linear differential equations have to conform to a given form before they are considered linear. So a first order linear differential equation is said to be linear if it follows this form. You have the derivative of the unknown function. You have the unknown function times the p of x expression. This could either be a constant or an expression which has the x variable only, and the q of x expression here, which is solely a function of x. So when the form of your first order DE is like this, it is said to be linear. And just like the inexact DE made exact, we're going to use the integrating factor IF here. In some textbooks, it's represented as mu x, in some it's represented by phi. So let's have a representation for the integrating factor for this particular example or type of DE in terms of mu x and phi interchangeably for the integrating factor. So our integrating factor is e raised to the integral of p of x dx. So whatever is this p of x here, you're going to integrate it and make it the argument of this exponential expression. Then you will evaluate the integral of your q of x here and the phi, or your mu of x, which is the integrating factor. You are to get the integral of their product because it's the thing that you're going to place here on the right side of your equation, and the left side would simply be a copied representation of your unknown function and the integrating factor. So it's a three-step rule. Actually, it could be simplified into two, but nonetheless, if you wish to get first the integral of the right side of this expression and simply plug it in this formula, that would be fine. So let's have this example for a linear differential equation. So you have been given x dy dx plus y plus 4 equal to 0. Looking at it first, it does not look linear. But if you're going to divide the entire equation by x, it would be dy dx plus y over x. And you transfer the 4 on the other side, it would be negative 4 over x. In this form, your DE is already linear. P of x is this 1 over x here, and you have the unknown function y here. And Q of x is all the expression you see on the right side. So under step 2, you will find the integrating factor for this expression. Find the integrating factor. So you have e raised to the integral of p of x, or that would be e raised to p of x is 1 over x dx. If you integrate this, that would be an ln of x, and giving you a phi, which is an x. So in the case of the last step, you're just simply going to follow this formula. Your y, your unknown function, is copied. It's multiplied to the integrating factor phi x plus the 4x. Where is this 4x coming from? So the 4x is from this one, the negative 4 over x times x. And that should be integral of negative 4, which integrated would give you in negative 4x. But since it's on the right side here, if you're going to transfer it on the left, that would be positive. And again, the c we write on the right side of our DE. So this is how we solve a linear differential equation using the method of integrating factor. But first and foremost, you have to make your DE as given look linear. If it's not linear, then don't make it, or don't insist in making it linear. Probably it will fall on any other forms of first order differential equations.